It's 3 o'clock. Let's call this meeting to order. Very good. Item number 1.
All right, this is an update on the
Groundwater study.
So Mr. Scott Goldman is gonna lead us through this.
I will stand up and I'll point, but Erica's going to be helping me
Actually,
with the presentation.
I don't think I have enough for everyone.
it's like as long as we get one there,
Okay.
one there,
Oh, okay.
But I can send it to you.
one there, and one there. That's all we need.
All right.
Okay.
Perfect.
Well, there's 2 more if anyone wants.
So,
So I'll move this over here so I can
Yep.
figure out how to do this. No. What did I not
Do you
do?
have to?
do you want me to close this?
There we go. Okay, so I'm going to just give an overview of the groundwater basin and the information that we were able to find out about the basin. And then the details on the 3 options that we developed. One a non-potable, strictly non-potable option. One a desalter, where we would take the groundwater and desalt it. And the third one was looking at the reuse, where we do potable reuse. So we'll talk about each of those, the costs that we developed, the conclusions we reached, some funding options and how that might impact the costs, and then some recommended next steps. There are some next steps.
Good.
So anyway, this is the basin. We're going to kind of build the information as we go, but the boundary of the basin, we have the colors don't show up quite well, but there's 2 district parcels that are within the basin. The district office up here next to the sports park, and then I guess this is your lift station 1.
Mm-hmm.
The other kind of significant land use elements within the basin, the old, this is a hazardous waste landfill, Armalite?
It was a
Yeah,
manufacturing.
Oh, manufacturing,
It's
okay.
now a multi-family development.
When I drove through, probably on the way here,
Yes.
on Armalite Drive.
Yep, that's
Mhm.
it.
Yep.
Okay, and then the Bradley landfill, so both of those potentially could impact the groundwater treatment facility.
There was no further study upper in the Twin Oaks up there in that area?
Study.
Well, the ground.
Not in terms of groundwater, this is the basin boundary as defined by DWR, I think.
Yeah, I mean, outside that, there's no defined basin.
We do have some wells that we have some information on outside of the
Yeah,
basin.
but because I'm familiar with at least 2, 3 of them out there.
Well, let's go, so we'll go to the next slide, which shows you the wells. So these are the
Huh?
well information that we did find, and James and Rob did a lot of work trying to get as much as we could. You'll see the ones that overlie the basin, and then there's a few of them outside the basin. And the production numbers are kind of, you'll see ranges because a lot of the information is not consistent. Some of it's pump test when they originally drilled it, maybe like the Eubanks well, I think was a long time ago that was
Yeah.
drilled. What the actual production was on a sustained basis, we don't really know.
Yeah.
The same like on the sports park, we made some estimates. We have I think most of these are like pump tests that we got.
Yeah, well, the city had a list of wells and capacities, but it wasn't really clear, was it the pump installed or what that number meant?
Also, Jim, some of the pump tests were done during the wet season, and then other ones they were done during the dry season.
Mhm.
And the pumps weren't that far from other pumps, and there were drastic differences in some cases, not all.
Mhm.
And the basin is fairly shallow, and a lot of these wells are deeper, so they're probably pulling out a fractured rock, which is probably why we get, wet times we get water, and when it dries we don't. So it was highly variable. And then even like the ones right next to the creek, like this one, you'd expect it to be more, but we really didn't get that much. So it's a pretty undefined basin, but this is what we got. Ranged from as low as 16. I'm not sure about this 400 up here. That might have been a one-time pump test that they did. The Brandon Las Posas, the 200 to 600. Do you remember anything about
I think
that
600 was on the well log, and I think it said 200. They maybe did pump test or something.
And then the other thing that you find is it generally follows the creek. So if we were going to do something down here, then this site might impact us because it would move in that direction. Where the Mission Sports Park as well is probably upstream of that and is
Scott, how many of these are still active?
Well, all the city ones are still active, but they don't seem to be metered, so it's hard to get data on them. The Marcon Products one was just drilled like 2 years ago.
Mm-hmm. Yeah, we forced him to do that.
Okay.
We sent him a big bill.
That's
And he
ki-
came and
that's
said,
kinda what they
what am I
said,
gonna do
right?
now? I said, drill a well.
And just there's some work with, especially areas that are on wells that also have meters.
Yeah,
And then we looked at our meter records compared to their well to try and figure out, but we know they're not using their well in the middle of summer.
Right.
So how much water are they taking, and then can we kind of back into a guesstimate of how much water do they produce during the normal, a little bit of guesstimation.
Yeah, and we did that with Mission Sports Park, cause we know how much turf they have and how much irrigation water you sell them. What they
Mhm.
probably should use, and I don't remember.
Well, that's how we got more like the 25 to 50
It's
gallons
probably
per
what they're
minute
doing on a
So
sustainable
average.
basis.
Are those all city wells with the exception of Marcon? Are the rest of them city?
Eubank is private.
Yeah.
Right,
Yeah,
which,
that's true. That's-
Hollandia's private. Oh no, that's the park.
That's the
sorry.
park one. Yeah, so
Yeah,
they're,
there is
they're
one
all
in
city
Hollandia,
except
though.
Marcon
That's a
and
park one.
Eubank.
Okay.
so then we also were able to get some, information on quality on some of them. And it surprised me that the quality's not that bad. We highlighted in red those, there's a few of them that were over 1,000, parts, but several of them were under 1,000. Not drinking water quality, but not that bad. I mean, probably close to being able to use this for irrigation, which I think is what a lot of them are used for.
Yep.
So.
Wonder why Hollandia is so high.
What did you
Going
do?
up there.
They also have nitrate there, so I think you guys.
And you said cows there.
Yeah.
Yeah. Cause I know, the, Diamond Environmental has a pump, a well that they've done. And their contention was ready to drink. Who knows the reality, but,
Well, I would say these wells are ready to irrigate,
yeah.
but not ready to drink.
Just because it's clear doesn't mean it's ready to drink.
Yeah, and as Erica said, there were other constituents that we looked at, we just simplified it on this slide.
But there wasn't a lot, so there was some chloride data, nitrate, and then some older like iron and manganese and things like that. But there wasn't like a full Title 22, so you wouldn't know if you could drink it.
Are the wells along San Marcos Creek higher in nitrates?
I don't know if we had data for Creekside and City of San Marcos. We had Town Center.
I think we have a slide in the back we can go to that has some of the other.
I would guess that they are, since there's a problem at Lake San Marcos.
Yeah, a lot of that.
Most of them don't have
A lot of that
nitrate
problem
data
goes
attached to
from
them.
the turnover in the lake, the contaminants that they got
So
to
we
build
had-
up into the
So
bottom.
Town Center and Public Works are non-tech, but Hollandia had like over half the MCL.
Yeah, and then we didn't have water quality data for either one of these two. So the other thing we were trying to do was a water balance for the basin. So we have the Todd report, and in the Todd report, they estimated that the recharge from rainfall is somewhere in the 3,000 range, and just the amount of irrigated water that's applied is about 1,500. So they're saying that the recharge into the basin from the surface is somewhere around 4,600. We just looking at the wells and the range of numbers we got, we figure the extraction's in the 400 to 800 range. So, and we don't know what the inflow is or what the outflow is. But, so there's a lot in between. So it's, if it's 4,000 to 5,000 going in, and there's only 1,000 coming out, then there should be the potential to withdraw more. For our purposes, we assumed that the extraction that you could get would maybe be 500 to 1,000. But we used 500 for most of our analysis when we were looking at it. And because there seems to be much more water going in, and because of the way the basin is fractured, that we were assuming, at least at this point, that if we took 500 out, it probably wouldn't impact anybody else as well. I mean, it's possible it would, but with the fractures, it's, you could have two wells right next to each other and not have any impact and be miles away, and you might. So for our purposes, we used the 500 for new extraction. So the three options, non-potable, we looked at three different systems, with these as kind of the main target customers. And I should also say that for the wells or the treatment, we use this property, because you have enough space to put some wells and a treatment plant on this site. So we use that for our starting point.
And just to be clear, that included potentially using the hill property,
Using the hill property.
portions of it, yeah,
Yeah, for reservoir storage.
for reservoir storage, because we need the elevation.
And you'll see it in some of the maps that we
Okay.
have. So we did 3 different options on the non-potable. We said, well, what if we go out to Palomar College as our main target and pick up anybody along the way? Twin Oaks Golf Course, it's the biggest demand around, but it's a distance away. So we looked at that one, and then we also looked at Cal State and San Marcos.
Now, I know Twin Oaks has got a well, a golf course.
Yeah.
Yeah.
But they've also approached us, the general manager actually, and are willing to do a guaranteed take.
Yeah.
Oh,
Because when they have to go after well water, the price of potable water is way too expensive.
yeah. I don't know if Palomar has a well, or CSU San Marcos has a well.
I
Any
think
idea?
they do,
I don't think Cal State does.
Okay.
I don't
Well, on
think so.
record, they have some, but I don't know if they use them,
Cal State?
yeah.
Oh,
They have big meters from us, so,
yeah.
both of them do.
And I think it was your meter data that we used
Yeah.
for our demand estimates, so.
Right.
Right. So yeah, if they did have their own wells, that'd just be on top of
Right.
their usage with us.
So in other words, we use our meter records, so when we know how much irrigation they use. So if they use their wells, we're not offsetting that.
Mm-hmm. Okay.
So that was the non-potable, 3 options, and we assumed no treatment would be necessary to be able to use the water straight out of the ground. For the potable salter option, so there we assumed we would have to desalt at least 50% of the water, get a target on something under 500, and then we'd have to do assume iron and manganese removal, I think, on the other half, and then the water would be blended back, and then it would be suitable for introduction to the drinking water system.
Hmm.
Very similar to what Oceanside does with Mission to Salter and what Leeuwenhoek is in the process of developing in the San
Mhm.
Diego Basin. And we use the 500 acre foot size in our economics.
So if we did this, just so I'm clear, if we did this, we could add 500 acre feet of potable water
Correct.
to
Local
our
supply.
use.
Right. And in these 3 options, all 3 of these were less than 500. So
Mhm.
again, we're assuming we're able to get enough extraction to get, I think 350 was the golf course.
Mm-hmm.
And then the potable reuse option, we looked at if Encina did their potable reuse project and brought it, the advanced treated water out here, the additional cost then to get that water in the ground and out. And then we also looked at Meadowlark and said, well, what if you added the advanced treatment of Meadowlark and brought that water back into this area and did it here? So these 2 options, we wanted to compare those 2.
And these are IPR type options, Jim, so not.
Yeah, right.
Okay.
Right, so it would be either Encina or Meadowlark with the advanced treatment, would inject it in the ground and then pull it back out and then deliver it.
Lot more boxes.
Yeah. And conservatively, you've used 500.
Yes.
We used 500 acre feet for this one, and this one, we assumed you could get 500 plus whatever you inject. So, because you're injecting water from the advanced treatment plant, you actually can produce more water.
Mm.
Because whatever you inject, we assume you're gonna be able to recover, and if we put in wells, we assume we're gonna be able to get a little bit more than what, you should be able to still get the 500 out.
So the 500 was a non-augmented safe yield.
Yes.
Correct. That was our assumption. Maybe it's higher, but you'll see when we get to well production assumptions, the wells out here don't produce a lot, so 500 would be on the order of 300 gallons a minute, 300.
Mm.
So, we're going to be less than that on. We take several wells to get that 500.
Okay.
So for option 1, so this is the district's property, and as James said, we have the tank up on the hill, and we looked at multiple wells, again, depending on how many wells and how much we were delivering. So for the 3 options, With the Palomar option, we're looking at 150 acre feet. That would be offset. The Twin Oaks would be, and that pipeline basically would run over here and up to Palomar. The Twin Oaks golf course also picks up, well, here we'd also pick up the middle school as well as the Windsor apartment are right next to the district, so we would pick that irrigation up as well. And then going up to the Twin Oaks golf course, we'd pick up that in the apartments. And then option C, going down to Cal State San Marcos, we're also able to pick up some Caltrans irrigation in another apartment complex. So we end up with close to 300 acre feet on that option. And then for all of these, we really are more concerned about the daily. The summer peak, so we had gallons per minute. We need the wells to be able to produce in the summer, and assume we'd have to store it in the tank during the day and then deliver it at night.
Mhm.
What size tank do you envision?
I think we were looking about a half an MGD.
I don't know if it was on the
Put in.
slide.
Half a million gallon?
Yeah, usually it's one day. You want to have at least a day's.
And
That's a pretty small tank then. 'cause-
physically, how,
Very big.
give me an idea how big that is.
We have a half MGD, or is it a 1 MGD tank, Rob, on Twin Oaks
Actually, we
number
might have
1?
assumed one.
Twin Oaks number one's
No, Twin Oaks.
0.57.
So
Yeah,
it's
it's about that.
pretty, it's still, they're still usually 32 foot tall though, but they're, I don't know what the diameter would be, but it's pretty darn small.
Math is.
20 feet?
Yeah.
I know. So,
I mean,
no,
we're
it's
talking
very
20
small,
feet?
More than 20 feet.
40?
So,
So what size?
The tank's
I'm trying
only,
to, I'm visualizing,
270,000 gallons.
Oh,
It's
Come on,
less than
small.
40.
Okay.
Yeah.
I'm visualizing the grief I'm gonna get from Mike and Hal when we mention storage tank on the property.
it's okay, this is not
Do
the
you have
preferred
a,
option.
do you have a
yet.
really
Yeah,
small tank?
okay.
Because it's actually only
Yeah, 'cause
So,
Scott,
yeah.
we're,
Oh, no, I don't have
we're
a tank
looking to
that small.
redevelop,
Okay.
to develop that adjacent
Oh,
property,
okay.
so.
All right, well, that would be an avoided profit then if we did.
Yeah, well, we'll just have to paint it and turn it into a feature.
Well, they're cutting down the whole hill though.
Yeah.
So,
So then you wouldn't have your elevation.
Yeah, then
You wouldn't
you
put a
wouldn't
tank
have
there.
that, but that's okay, luckily this is not the preferred option.
Okay, okay.
Shh, don't spoil it.
I do
It's an
not make
option.
Spoiler alert.
Well, the other considerations on this one is the Palomar College. We don't have the cost of what it would take on the college. And that one, I believe, is mixed use and would
Yes.
probably be very difficult to retrofit.
To
So-
separate the systems.
Yeah,
Yeah.
Palomar has a loop system where they have their own on-site system where they have irrigation and portable lines that come off of it.
No,
So we'd have to run a line within Palomar College to pick up their irrigation system. So
And the same with Cal State San Marcos.
The
It'd
same with Cal
probably
State San
be
Marcos.
more difficult. Now, you go to the golf course, then that's a lot simpler. They're probably taking all their water in one place. I don't know if they have lake storage
lake
there,
storage, yeah.
so you might not even need the tank if you serve the golf course.
I put a lot of golf balls in their lake storage.
Okay. So they have less storage than they used to.
That's right, a little bit, yeah.
yeah. Or if he keeps on playing, it'll.
That's right, pretty soon it'll be none.
So the desalter option, so now, this one what we looked at here is the 500 acre feet, but then we looked at how many wells depending on the production. So we used 50 gallons a minute to 200, so somewhere in that range. Based on the data, we think we could get 50 gallons a minute on the low end. We also did it 100 gallon a minute. That's probably a more likely number on the high end, but 200. Some of the numbers were as high as 200, so we included it just to see what the impact
Mhm.
was. So we have 7 wells shown, but you might need 2 to 4, maybe 5 wells. And then we had just identified a location on the site for the desalter. This would be the, and then we have to have the brine disposal. So that would come back and we would just go back to the sewer. It's a pretty small amount of brine. We're talking about on the order of 10%, 10 or 15% of that would go back, so there would be really no impact on the sewage. And then we connect over here on into a main drinking water emission main, which then connects up to your Palomar tank.
so we would desalt it and then put it back into our line, take it right up to our tank and deliver it to our ratepayers. Is that it?
Drinking water.
Hmm.
And again, we think this would be located upstream of the other sites, so it should not be impacted
Mhm.
by the other water quality.
Where would the pump station be?
It'd be part of the desalter,
Yeah,
so.
not
Put, it's gonna go with the dissolvent.
It's not a tremendous amount of gallons per minute we're talking about.
It's a pretty small facility.
Yeah.
And what size of the footprint would that desalter be?
I don't know if we had that in there,
This,
so
this
we,
room?
we're doing about the same size in the Levine desalter. They're
Uh-huh.
doing, well, they're doing 1 MGD, this is,
Yeah.
this is about a half.
Yeah.
So we use the cost and
Yeah.
we use enough to get the footprint. I don't know if we have it in the report, I don't remember. It's not, it's not huge.
Do you
No.
imagine it would just probably be another building in the yard,
Yeah.
something like that?
Yeah,
Yeah.
we just find space for it in the yard, and they have a small pump and a backup pump system.
Mhm.
And I've seen desalters, and it's basically about the size of this room, probably at the most, I'm thinking, or is it a little bit bigger?
Depends, yeah.
Well,
I'm
with the
thinking of
iron, with the iron manganese vessels, it might be a little
Yeah, I'm
bigger.
thinking of ocean size, but theirs
But
is like
theirs is
six
big, yeah.
6 MGD, so
Yeah.
theirs is probably 3 times the
I'm
size
thinking,
of this
I mean,
room.
I think the iron manganese filtration tanks are gonna be like this, so
Yeah.
not, you know.
Well, I suspect we're gonna ultimately end up going to the board with this information, correct? So if you had that information,
Yeah,
so people would know, A, how big that tank would be, footprint, and how big this desalter footprint would be, people get a better visualization.
Good point, we'll
Yeah.
do that. And then the third option is the potable reuse option, where we would take the wastewater from, the advanced treated water from Encina, and we took them both to the same location. So, this is the point of connection that Encina was proposing to tie in to the raw water, aqueduct from the Water Authority. And so we looked at, Meadowlark, putting the advanced treatment there, and then bringing that up to the same location. And then from there, we'd have to run a pipeline up to injection wells and then pull it out through extraction wells after it's done its travel time through the basin, and then we'd have to pump it back up to the Palomar tank.
Mm-hmm.
So
Is that basin big enough to give you the residence time you'd need for the
we
indoor?
didn't really look at that.
Okay.
We just, this was actually in your master plan, so we used the same layout that they had proposed. What we did do though is we said, okay, if we're at, depending on the number of, how much extraction could we get? Injection wells are usually half the capacity of an extraction well. So we said if you've got 100 gallons a minute on your extraction, then you're only gonna get 50 on your injection. And if you're 200 on the extraction, you're only gonna get 100. So we didn't look at the 50 and 25 because it was just too many wells to make sense. So we limited it to the number of wells, so that actually allowed us to go up in size. So we're looking at 1,300 to 2,000 acre feet. So you could potentially, if we got the bigger extraction, if we could get the 200 gallons a minute, then you could do up to 1,500 acre feet if we could fit the 10 wells and make all this work.
But that would include Encina's water coming in as well?
Encina or Meadowlark.
Okay, whichever.
Meadowlark.
Yeah, it's either one. So we looked at both, and then
Uh-huh.
cost we have both. And you'll see that Meadowlark's actually less expensive than
Mm-hmm.
starting with the Encina water because they gotta get it all the way to
Yeah,
you
right.
and the cost there. So this one actually produces the most water, for you, cause we also have the 500 on top of this.
Oh. Mm-hmm.
No, I take it back. That's already factored into
Yeah.
this.
Yep, yeah, 1,500 injected, 2,000 coming out.
Right.
Right. So, we went through and developed all the costs for all the options, the 3 non-potable, the desalter, and then the 2 potable reuse options, capital costs, the amount of water, and then this is the dollars per acre foot. So what we highlighted here is in yellow, you can still see the numbers, that's in the 2,500 or less range. So the 200 gallon a minute options, of course, all of them are, they look pretty good. We only had 2 options, the non-potable to Palomar or the desalter at 100 gallons a minute. That was in that 20, those are basically equal in cost. Although you get more water, you get 500 acre feet out of this one, you only have 150 acre feet out of the first one. And the capital cost, 14 million here versus 5 million.
Oh,
on the first one.
Scott, was there any risk assessment, so if you did, like, say, option 2, and you assumed you can pull 500 out, if you could pull less, or if you actually can extract more?
We didn't, no, we didn't do that. Could, it'd be easy enough to do. We were more looking at the amount of production.
Okay.
So you would, it would obviously bring down the unit cost if we're able to do 1,000 instead of 500. And we'd still probably be limited on the 100, whatever the withdrawal rate is. So that, you're gonna get economy of scale on the treatment,
Right.
by doubling it in size. Adding the wells should be
Yeah,
pretty
and it looked like
proportional.
200 gallons per minute was kind of the ceiling just based on the
Yeah.
data that we had from all the other wells within the valley.
Basically, we were talking with Scott and Rob and I talking as staff internally, we felt that 100 gallons per minute well production is a safer bet. 200 is possible, but if we look at something that at 100 gallons per minute, and that's something that we move forward with, if we get 200, that's a bonus. That's, that brings it down.
Is that 100 throughout the day? Is it?
Yeah.
It's assuming it year round.
Okay.
too.
Year round,
Yeah.
that's what I mean, cause when we looked at the data, there's at least for me, I'm pessimistic about summertime productions of some of these wells.
Yeah.
So,
Right, and I'll tell you, I know that there's a few of these desalters up in the San Juan Basin, southern Orange County, and they run years like this where it rains they'll run all year when it's a wet year, but on the droughts we had, they were off for 2 or 3 years. They just didn't have enough.
Yeah.
There wasn't enough local input. But I think your point's a good one, Glenn, that, we base it on 500 acre feet, and so if we did 1,000 acre feet, even at 100 gallons a minute, it's gonna lower the unit cost.
Is the unit cost, is that all in, is that all the capital and O&M?
Yes, for these options, it is the non-potable, we didn't capture any of the on-site cost, but we've got everything else factored in, so that's basically, we only showed the capital, but we also have the O&M included in an amortized capital.
if that was a 1,000 acre feet, how dramatically would it reduce the unit cost?
Well, it's gonna have to include that. So I think what we wanted to do was get feedback today and then sort of narrow in on the option that we wanna center around, and I think, and we're certainly leaning to option 2. So we can then look at 1,000 acre feet and see how that would impact the cost for that option, and then.
And maybe the other way too, what if it's only 250, if it doesn't
We do
produce
that.
quite as much?
Right.
Yeah.
And my
Sensitive.
guess is it's gonna raise or lower at $500 an acre foot. It might be able to drop it down to 2,000, but you might be up at 3,000.
Yeah, okay. All right.
So, I don't remember what the next one was. Oh, so our conclusions.
John, what was
So the feasibility is really dependent on the amount of extraction. The non-pull options really require the 200 gallons. The one that worked at 100, when you factor in the on-site costs, they're not gonna make sense.
When you say required, just to get the price down and a reason.
Yes,
That's
they
what
get
you're
that,
saying.
and we kinda use that, just, go backwards.
Oh.
Okay, so if you looked at where the costs sort of split, it seemed like 2,500 was a good round benchmark.
Yeah.
Cause then you're starting to go up, the next one group was sort of around 3,000 or more, and then they go up from there, so.
We're paying about 20, almost 27 for diesel.
Diesel, yeah.
But I mean, if you go forward and you put in a test and it produces 50 gallons a minute, and that's what you're gonna get on the site, none of those options look very pleasant. So,
So for the non-potable project, there aren't any private potable wells that are down gradient of where you would inject?
Not for potable.
You did a search through DWR on wells, and we didn't find anything.
Yeah, nobody was, it's all irrigation or
Yeah,
the Marcon
so
one
we
is
don't think there's any.
construction.
Okay.
I guess the thing that's attractive somewhat about option 3 is you have control. You can bring
Yes.
the water there.
Right.
So you're guaranteed of being able to pull some back out.
Right, and that 500 adder, if that goes away, you're still pulling out a
Right.
decent amount of water.
but you may not. If it's a fractured rock basin, you could be injecting into one vein,
That's
and
true.
you may not find the vein downstream. So
Right.
there's still risk.
Yeah. probably smaller, but there's still risk,
Yeah.
yeah.
And correct me if I'm wrong, but these options aren't necessarily mutually exclusive either. Are they? I mean, you could start with one there.
Oh yeah, you
Yeah,
could
that's
start
true.
with the
Yeah.
desalter and then go to injection and see
Yeah,
if you get
sometime in
increase.
the
I mean, that's
future, yeah.
basically what Oceanside's doing. They started out with a 2 MGD desalter, and it worked for them, so they expanded it to 6. And they only get 4 out of the ground. They don't get enough, so now they're going through the injection project, and that's to get them up to the 6. So
Just
they're
don't
just
strand that asset.
Yeah.
yeah, so, you know, it's considered potable by the time it gets to the desalter, and then over time, you're putting in such high quality water that the
Clean the basin.
expectation is they're not gonna need to use the desalter anymore, cause it'll be clean groundwater that they're pulling out. And then they're gonna have to, do something to the basin to make sure other people aren't putting a bunch of
Yeah.
Steal their water.
Right.
That's a whole different
Good
issue.
investment.
Yes.
Right.
Any other questions? Oops, oh, you went ahead of me.
Sorry.
Anyway, so, yeah, so the potable desalter option makes the most sense at 100 gallons a minute of it. And then, of course, there's a lot more study that needs to be done on the quantity, to try and nail down the quantity and quality of the water. And so,
Go ahead, Jeff.
okay.
And Scott, I know you didn't do a legal analysis of groundwater rights type of thing, but do you have a general sense of the risk of somebody else?
Well, we
claiming-
have a sub,
Yep.
but that will do that for us. They're included in our contract, and
Okay.
that's one of the questions: do we want to do that or not?
Do we wanna spend the money?
Right.
So,
Because
Because
I've-
it was like $10,000. There's not really a lot of info for them to work with either,
Yeah,
so
so
it's like,
Your results.
she's
may
gonna
be-
give you something really general, so it's like,
Yeah.
is that worth it?
from our discussion, it seemed like if, there's a desire from the committee, obviously with upgrades to go, and then to the board, to move forward, kind of using it towards that, if we move forward, would make more sense.
So just touching on the funding side of things, we did not include any outside funding in those costs, so that $2,500 range is fully burdened. The local resource program, of course, you can get up to 475, offset that as, when you produce it. That 475, I think, is the 15-year
Yeah.
payout. There is the Department of Water Resources that have grants up to $10 million. They'll do a 50% match. And the WIN, this is the federal, of course, have to apply for it. And we just wanted to put that for the potable desalter option, we're in that 11 to 14 million. So you have a expensive enough project to get the 50% match on this project. And which one, this is the one I think Allevenheim is
Yeah.
getting?
The DWR
The
one?
DWR
I
one.
think so, I think we got that info.
Yeah.
So if
anyway,
you,
that's how they're offsetting.
if you
some
get a
of theirs.
portion of that even for your project, you can dramatically reduce the cost of that water.
Yeah, cause I remember that the desalinization was like 14 million?
Yeah, it says right there.
Oh, yeah.
Oh, it's right there,
Yeah.
14 million.
11 to 14, depending on how
So
much.
if, and you know, if we got 10, we're gonna end up
Well, the
But
most
you
you
could
get is
get
50%.
seven.
So the
50%,
most-
so it's 7, yeah.
Right,
Oh.
and then you could still get the 475 on
Mhm.
top.
So if you got both, you're cutting that water cost basically in half about it.
Yeah.
Scott, is there another slide then that shows if we were successful in that, what does it do to the unit price of water?
We didn't create that.
Okay.
I didn't wanna
But
give
we
you too
could.
much optimism.
Wait, we're waiting
Yeah.
for this meeting,
Okay.
to see what you want.
But that would be a next step.
Yeah.
I don't want you guys to see water at $1,000.
Yeah. That's what Jim wants to see.
You're darn right.
So I will tell you, I think Oceanside got some federal desal money, because that was a new program that they started last year.
Mm-hmm.
So they got some federal money I think they got the 5 million or something. No, it was 25% match.
Yeah.
I think the win was a 25% match, so I think they got 2 or 3 million. The DWR money, I think it's a limited pool. I think this is money out of Prop 1, and so this is available while it's there. I don't know how much. I think we asked how much. I don't know if you got a response back from our funding.
I don't remember, but if people keep passing water bonds, then that would probably be
Well,
refreshed.
there is still money left in the Prop
Right.
1, but I don't know how much.
Yeah.
We were checking on that.
Okay.
to
So
see.
we have another slide about,
Okay.
so I mean, with the existing money, we don't know if you can get 10 million, but you could probably get money for a feasibility study
Right.
out of them.
Yeah, and
which is the first
we haven't really done a lot of work on how much this next step would cost, but we're guessing it's somewhere in the $500,000 to $1 million range to really do the groundwater investigations. We had, looked at some other basins and they had spent 300,000 or 400,000 just on the groundwater studies, but they were more sandy with a fractured rock basin. I'm not sure how much that changes the effort, but we expect it's somewhere in this range.
What is the effort? What would you be doing in the next phase?
You would be doing test borings
Okay.
in the locations where you wanna put the wells and then seeing how much water you could get out of it for how long.
So you'd actually be doing test wells?
Yes, that's why, I mean, they're not huge wells, they're not
Right.
production wells, but I'm starting to get out of my area here, you know,
Yeah.
probably 2-inch test bores or something, and then you start pumping them and see, and then you extrapolate that into a full-size well. And then we'd also do the water quality sampling, and it would be on test wells here on the district's property.
Yeah.
So
And we
the-
could also start on some of the existing wells that aren't metered, so if you wanna put in a meter emissions sports park,
Yeah,
test
we'd have
that
to get
well,
permission, but.
that would be a start.
So the opportunity is a maximum of $700,000 from the DWR with a 50% max,
Match
50
it.
match.
So in other words, if we had a $1 million study, we could get $500,000 from DWR, and you get $150,000 from USBR.
Mm-hmm. And then we make up the difference.
Yeah, and these would be the applications.
Yeah.
So,
Mhm.
If you wanted to proceed.
so you know, so a lot of that study can get paid for a significant portion of it.
Right.
So it's not, you know, you're not looking at a true $1 million price tag if you're successful.
Yeah.
So.
So that would get us some kind of production data and quality data.
Right, and then
Mhm.
hopefully that would help us narrow down whether that 100 gallons a minute is
real.
reasonable. or
That's,
not.
that's test wells. That's probably a year of testing for production, water quality. That's some mapping involved based on that information. Of course, feasibility report, stuff like that. Is
Right,
that correct?
and that's where we are with the Lebanon right now. They just drilled the test well, and I think theirs project was, I'm not sure if that's where the 700,000 came from.
Yeah, I think so.
Well, the max is just what's in the old
Okay.
grant.
'Cause I see, 'cause they got, I think, 300,000 for their test project, and they drilled the well. They were expecting to get 600 GPM. They're in a much better basin down in San Diego, and I think they're at 400, so,
Is there an opportunity to work with existing wells and work with the owner of that well to see how consistently that will produce, even if they don't have necessarily the demand for it, but they have the investment already?
Yeah. But the drilling of the wells isn't tremendously expensive. But the well has to be deep enough and everything else. I mean, like a 2-inch well doesn't cost that much
Yeah.
money. So.
Yeah, I don't know what the
I-
cost is.
So I just want to bring it, this has all of the information we had on the wells in terms of the quality. The Mission Sports Park is the closest one to you, and seems to be producing a decent amount. You could probably do some
Yeah.
tests
Yeah.
there. There's also the Corky Smith well.
Yeah, the
I
one
don't
over at the
remember.
Boys and Girls Club. Yeah.
Okay, so I would think, we'd need to engage with our groundwater people and find out how, I would assume that's what they'd wanna start with, that's what Lebanon did. They worked with some local well owners and they
Okay.
did some pump tests on the existing ones to help better characterize the groundwater basin.
What do you do with the water that you pull out during the test period of the test?
They're gonna irrigate with it at the, surf, what's that soccer club down there in San Diego?
Yeah, sure.
Oh, really?
Yeah, so anyway, we're kinda over irrigating that area year round, I think, so. But you could put it in the sewer too.
So
They
if-
didn't have a sewer available.
If you'd used the 2 wells there, what would it cost to get the applications put together for a grant? I mean, is that tens of thousands or?
It's a good question, let's ask.
And I did ask Sally, but I need to check, so the wind planning one is supposedly easy, although I'm suspicious of what that means, so I need to ask her again what the cost was. And the DWR one is probably 20, maybe, or less, so we just have to look into it.
Okay, well,
Is that in this?
that'd be
Is it in
important
this
to know.
scope? I don't remember what was.
To
Uh,
do the
to do that,
applications?
no.
No, but we can certainly get the estimate and put that in there, to what it would take.
didn't we get a grant to do part of this study?
Not this one. no.
So the grant that you're probably thinking of, Director Hernandez, was for a recycled water business plan,
Oh,
which was, this is actually tiered off a portion of that. As you heard Scott say, they use, one of the options here to like cite, the extraction and production wells. And, that information was also transferred to the master plan, chapter 4 as well.
okay. All right. We were having a discussion. Do I remember this was a $50,000 event or 75?
We had 75 budgeted, right?
Yeah.
I think
Yeah.
our proposal was 70 with the legal.
Yeah, and so, okay, all right.
So where are we at with the scope? Are you, everything but the legal's been
So,
done, or?
yes, everything but the legal, well, we have a draft up to the recommendation section. We wanted to get the feedback from here,
Mm-hmm.
confirm that everybody was good with the potable, desalter approach, and then we can wrap up the recommendation section and incorporate the comments we got today.
And then from the staff side, and also Woodward and Kern, it's a matter of getting the direction from committee today, wrapping up those comments and bringing it back to full board for, do we wanna proceed with the next steps? What do we wanna do? Right now, we've kinda stopped short of saying it in the report, but I think, or maybe it actually does say in the report, is, moving forward probably with the, desalter project, correct? So, as recommendations for next steps.
Yeah, well, personally, putting that together with your recommendation at the end and tying that with the funding, so that the board saw all the information, and then we narrowed it down to what we believe the recommendation is, the desalter, and then, go get the funding and do the next step. 'Cause without the funding, well, let's see, just how much would we have to put in if,
Well, depends, so if it's $1 million, you're gonna get $500,000, you're gonna get $650,000, so $350,000 would be Vallecitos.
Mhm.
Was
Yeah.
it? Yeah.
Okay, well, then we need to have that data for them too.
And those two grant programs can work together. You can get
Yeah,
half
'cause
through
one
one
stayed and
and the
one
150,
stayed.
Okay?
Right, it just depends on the timing. I don't know when, I think annually the WIN applications come out, and then it takes 6 months
Yeah.
Mhm.
to hear, and I think they're out right now.
They're up right now, yeah.
Yeah, so this position.
And I don't
usually-
know if the planning's on a different cycle, so I have to check with that too.
It
Okay.
may be those don't go on a cycle, you just submit the
Yeah.
application and
Mm.
you have the project.
Okay.
Well, this is what I knew was
Is
gonna
this good news, Jim?
You were right all along.
I had this already in my head. I knew it was out there. These naysayers, a couple of people.
So we can
We
throw a
use
little
close
more
50,000.
sensitivity on that desalter option as far as whether we get less
Uh-huh.
production or more, and what that does to the unit cost, and then also what the funding would do to the unit cost.
Yeah, that would
Good.
be
Nail that into the
All right.
presentation and the results.
Well, good.
Okay?
Yeah. Anything else?
No, I don't think so.
Thank you.
I haven't seen
Yeah.
you this happy in a long time.
Yeah, man.
I know, he's smiling, that's
Yeah.
not a good.
Well, I knew there was some out there, but I didn't even know all the details, but,
There's updates,
you know.
but it didn't have the next steps, cause I didn't know what
Okay.
they wanted us to do.
That's fine.
Great. Well,
okay,
All right.
great. Well, that's
Thank you,
terrific,
guys.
Scott.
You guys definitely don't
Yeah,
have to stick around for the rest of the meeting, so.
Thank you.
Yeah.
So
I
they'll,
appreciate it, thank you.
yeah, so they'll wrap up the draft TM, based on the results of this meeting here. And we should probably have something, what do you say, in the next week or so, Erica?
I mean, it depends, are we looking at the funding for all three options?
No, we're gonna
Just
focus
the
on the
desalter?
recommended option,
Okay.
and,
Cause we kind of already have that done, so it could be, I
Do
just have
you,
to ask Martha what her schedule is.
When do you think we could take this in front of the board?
Well, let's figure that out when we get the report in.
Oh,
I'll
okay.
submit the draft report and
Yeah,
we'll-
We got a busy June, so.
Yeah.
Oh, June?
Yeah,
so
probably-
it'll
probably
probably be
July.
early next fiscal year.
Yeah.
All right, well then, because I'm gonna be gone, our first meeting is in the first week of July,
yeah, it's
And
July
the-
3rd,
so.
and the last one is third week of July, which is like around the 20th or something.
17th.
Yeah, oh good, I'll be
I'm
back.
thinking of canceling it or rescheduling it, cause it's the one on the 3rd is the
Oh, yeah, right
day
there, right
before, will
there.
be
Yeah,
a 4-day weekend for a lot of people, so
Well,
it's
I know I'm
Okay.
on that day.
Yeah.
not a good time.
All right, well, good, I'll be back by then.
Okay.
All right, thank you.
All right, well, thank you
Yeah,
very
Nice
much.
meeting you.
Thank you so much there, guys.
Alright.
Okay.
Item dose, huh?
Item 2, solar study, can we move into that next one?
Yeah,
Okay, so I think James, you're gonna handle this
Uh,
one?
yeah, actually, I'm gonna move over to Rob, but basically, as you may recall, basically we have two options that we're moving forward with, which is a NEM, a net metering site at Lift Station 1, and the second one is the RESBCT site at Twin Oaks, and
Yeah,
like
you
that's
should
a
sing that.
I know, I always want to. Resbit, the Resbit site, that's a better way to say it, at Twin Oaks, which is a 2 megawatt site. So,
and that's
what-
over the top of the tanks.
it's over the top of the tanks, and
Mhm.
so we've worked out, the RFP is done, drafted for both those to go out. However, we're in the process of doing CEQA. So now we have to do a mitigating negative deck for both sites. We don't anticipate really any problems with that at either of those sites. We've worked with operations about access to the tank and gotten their buy off on that. So basically, everything is done. The RFP to go out for providers is literally on the shelf right now. You know, everything's been done. We've already gotten legal review of it. And where are we on CEQA? Just a schedule.
Yeah, so CEQA's not, we don't anticipate that taking this long for a project like this. Probably 2 to 3 years is good. No, I'm kidding. So we
Be
got
quicker than the master plan.
yeah. Hopefully a little bit quicker. Than
Anything
the
that's
master
quicker than
plan.
mass plan is fast. Just remember.
I don't know how you went through this your entire career. Really, it's as slow as death.
So we contracted with BRG Consulting back in March for doing the CEQA. Held a kickoff meeting on April 10th, got them off the ground here. Terra Verde provided them with a lot of the data that they required to get their study off the ground. So BRG is currently in process of doing technical studies for the draft mitigated negative declaration, because that's what we think the appropriate document is going to be. So they're doing cultural, air quality, greenhouse gas studies at the moment.
For both alternatives.
Yes, yeah, for the whole package. And then we expect probably in the next few weeks, call it mid-June-ish, those should be wrapping up. I expect to be back before the board probably sometime in July to request approval
Yeah.
to circulate a draft.
It may be first meeting in August with the schedule, but yeah.
Yeah.
Right.
Mhm.
And then
Alright.
that'll just be a 30-day process there, and maybe by the end of summer, we
Yeah,
could probably
So
have
the
this
good
wrapped
news
up.
is we're working and we're going to parallel the process. So as soon as we know that we're kind of going through the process and we're going to go out, we're going to start with the RFP process. So this way, literally, we could go one meeting to certify the document. So you know, obviously after the 30 days, and then within the next few meetings, 2 to 3 meetings, actually have a recommendation for award.
Oh, good.
So we're having both consultants coordinate the effort to go forward. So this way we'll just basically run them one lagging right behind the other, just parallel. So we won't do it linear. We're not going to wait to certify the mitigating negative deck and then send out the RFP. We will send out the RFP probably during that 30-day process is what we're thinking.
So
Now, is there a recommended site that staff is pointing to?
No, it's those two sites.
Oh,
we haven't
so
changed the
both.
process. Yeah, both.
Right.
Oh,
We're
so
doing
if we do it, we're gonna do it at both?
that's what I was just, well, we don't know that.
Oh.
That's what I was just gonna ask James to clarify. So the RFP that's going out, we're asking people to propose on both.
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 Depending on what we get, we may do both, we may do one, we
Very
may do
good.
neither.
Yeah.
Yeah, absolutely right. So the board is going to have a decision based on the contracts, and with Terra Verde being the experts giving us a recommendation of what they feel is a good deal or not, based on going to the market.
Right.
We'll have a recommendation that goes to the board with the financials along with it. Because as soon as they get, one of the things that's the reason for the delay, as soon as we're not comfortable going out with the RFP until we're kind of in the 30-day process.
Mm-hmm.
And once they get the results from the solar providers, or not providers, but the installers basically, right? And the PPA agreements, they're going to rerun the numbers in their financial model to see what it makes sense. And then from there, we'll get a new recommendation.
Okay, great. All right.
And for the CEQA process, I take it the main impact is visual.
Visual, a little temporary with the construction,
Yeah,
during
that's
construction,
kinda always the case.
minor traffic.
Yeah.
Yeah.
May I ask what the CEQA contract cost?
Yeah, it was less than
Yeah,
50.
yeah,
Isn't there, isn't there
How much?
existing solar?
30?
30 and change.
Isn't there existing solar at Water Authority?
Yeah, that's why we don't think it's going to be much of an issue, because they already have solar on top of their 120
okay.
or whatever that tank is, 12 million gallon tank, whatever.
So
About
have they
34,000.
mitigated that visually? Have they-
We know what we're getting a copy of their document to see what they do. So
Did they put like
no, there's,
fencing?
sorry, there's no mitigation visually on that. If you live on the hill, you see the
Yeah,
yeah.
so
But-
fencing wouldn't block it off.
No, because people live above it.
Yeah.
So and if you cover it, then it doesn't produce anything. So. But the good news is there's existing use like that out there already,
Yeah.
and the other one's in an industrial with no residents. So I think we feel pretty confident.
Oh, good.
Knock on wood, you never know what comes out. So.
Oh, good.
That's
Well,
it.
that's-
Under, under the table, you got it.
Well, that's good, because I saw Kevin Ross at the Aqua conference, and he gave me the exact same update.
Oh,
Right.
well, there you go. Why is he stealing our thunder?
Everything matched.
I got
Good.
hey,
Good.
Quality
so we're
control.
being, so
Good
we're being
checking.
tested, huh?
Yeah.
Good checking on it.
Craig, you the answer already.
Hey, hopefully we instill a little bit of trust.
I didn't mean to check on you. He just told me all that stuff.
Got it. I gotta talk to Kevin about that. Just kidding.
James, did you want to do the CIP one to let these guys go, or are you okay?
No, I gotta do this one,
Okay.
and then because I may have to run out of the
Okay,
CIP
and
one.
they'll-
These
they'll
guys
take
got
it.
it.
Okay.
Yeah. Plus, I'm sure they want to hear about this anyway.
I'm sure they do.
All right.
All right.
Item next, asset management.
All right, asset management. So this is what I call, this is just a draft presentation. There's a lot more slides to this, but we want to kind of give the community an abbreviated presentation of what integrated asset management program looks like. And it may be different than what you think. So let me start with this. And I
And
put
remember,
the-
this kind of links to the item that we talked about
Yeah.
with the budget
Yeah.
last time with the asset management
So-
supervisor.
I put these dates down because it's a 4 to 5 year process to just develop the program. Okay, and basically what we're looking at is basically an integrated asset management (IAM), and there's actually a society called the IAM Society that Rob and I go to these meetings about quarterly. They're held at the Water Authority Operations Center, and there's professionals from the industry that give presentations. And then of course I've been going to the Utility Management Conference on Asset Management, which is put on by AWWA and WEFTEC every year, pretty much. So basically, you're looking at facility planning, capital financing, and facility operation maintenance. Now, we do all these things, and some of it has some integration with it. We do a fairly good job here, but they're not fully integrated from comprehensive ways. Looking how do we manage our assets, and then historically, it's been about condition assessment. That's only part of it. That's part of the building blocks of it. It's not really the whole thing. So what we talked about at the board, and I think a lot of misconception is asset management is about condition assessment. You assess it and you figure out what to do with it. And that is true to an extent, but that really sells it a little bit short. So today, we basically all tasks that are performed over the life of the asset can yield the most value for the utility. So the purpose: maximize the asset value over its life cycle. Pretty simple. I mean, that's a common kind of tagline for it, right? And it's an organization-wide requirement. So we have customer expectations. They turn on the water's there. They flush the toilet, it goes away, right? Their interruptions are nil to none. That's the customer expectation. We have our own business processes that we follow. What life do we want out of it? How are we funding? How are we financing it? What technologies? What's our rate of return? And how do we maximize these assets? And then, of course, the culture, customer service culture. What level of service do we want to provide our customers? Does it meet their expectations? Does it exceed their expectations? These are all things that kind of go into the building blocks of asset management to see where do we want to spend the money, where do we want to put the efforts, where does the manpower go. So basically with the program, with asset management program, will take on existing programs used by various individual agencies, or in this case groups, and combine them. So so you guys may have heard Maximo, some people call it CMMS, Computer Maintenance and Management. That is a maintenance and operational maintenance group. So that has a function. It's an operational function. It creates work orders. And when we work on an asset, a basic piece of infrastructure, it records what's been done to it, right? On the financial side, it records the cost, whether it's labor cost, material, and equipment costs to that side. And on the engineering side, we have asset planning, where we go, oh, we're going to need a bigger pipe, or we're going to need another thing. and then also there's a replacement side. There's 4 real things going on. Asset management combines them into one basically decision tool. So it's not just assess, replace, or rehab. That's a big part of it, but that's not just what it is. So again, for the customers, it basically replace outdated systems, replace processes that are basically inefficient. So address aging infrastructure, backlog, deferred projects, and maintain our level of service. For the leaders is track and manage costs, materials, and labor. Manage the workforce needs and be proactive, preventative, so instead of reactive. And just to give you an idea, I don't have a really good number because we haven't done all the research, and I laid this on Jason like an hour and a half ago. But so he just looked up old break record data from 2003 to 2015 on ductile iron pipes. So this does not include any of the big breaks that we had. And the average pipe replacement when we have a break on ductile iron was $10,000 a break. We replaced basically 1 to 2 feet of pipe. So basically you're talking about $10,000 a foot on a break. What's our installation cost on an 8-inch pipe nowadays per foot about?
Couple hundred.
You say 3?
Yeah,
I use 5.
Yeah, well,
When
with
I
the road and
estimate,
everything,
yeah.
yeah. So 500. So you can see the difference between what a emergency costs, $10,000 or $5,000 if you want to say that's 2 feet, or if you want even if you want to say it's 10 feet, it's $500, right? So you can see the factors, the scale here. Obviously, if I start doing this data up to today with the big breaks that we had, it's going to blow it out of the water. Those big breaks aren't typical.
Right.
Those are big breaks. We've had an unlucky streak. Hopefully it's an unlucky streak.
There you go.
There you go. But so that's why I wanted to give you the ductile iron, because those are the more common breaks. The ductile iron breaks that are 8-inch lines.
And how many breaks have we had since?
We're going to give when we bring this to the board in the future, or bring this back to the committee, we're going to have a little better data on that. I
Okay.
don't have all that information.
For ductile, we have about 6 a year for the last about
Is that what it
8
is?
years.
Okay.
60.
For just on ductile.
So, and then make responsible investment decisions with accurate details reporting. Now, what we mean by this is we make a lot of good decisions now already as an organization, but this is going to quantify. You could understand where to put your money, especially if money's limited. What's the priority? And we'll go into that a little bit more. And for staff, access real-time information to actually make their job easier. Dig once, okay? If we know that pipe's bad, make that decision to make those repairs ahead of time so they're not out there 4 or 5 times. A lot of our breaks are repeat breaks within the same area. So something breaks, we go back out there, a year later, 6 months later, fix another hole. And then also give them more mobility, mobile access to the device in the field, so this way there's less process paperwork and that bogs them down, so they can get to their job, repairing that line, documenting, so on and so forth. So basically, it's in 2 phases. It's a 3 to 5 year process. Phase 1, starting fiscal year 2020, is really capital asset planning, asset maintenance program optimization. What's our priorities? Where's our failures? What's our failure codes? What do they look like? What do we assess? What do we ignore? What can run to failure? Where do we have critical areas in our system? That sort of stuff. Phase 2 really goes beyond that, and kind of go over it, and we're not going to really go over much of Phase 2, but Phase 2 ties in the capital, ties in the replacement, ties in the financing structure. So the board's already heard a lot about here's our ceiling, here's our floor for reserves, and that's based on this metric of 10 times or down plus 180 days, so on and so forth. But once we do a full asset management plan of replacement schedule of our $600 million in assets, we might know better that, hey, our reserve ceiling is way too low, or we're going to have to spread that capital outlay out a lot more, and is that possible? It will give us better decisions as a board and as management to kind of look into the future, and then also give us the ability to say, as we make improvements, how are we stretching that spending plan? Because spending money today and losing those opportunity costs of money is a lot more expensive than spending that money tomorrow, because it even costs more tomorrow. So, but you get to save. So, let's see. Oops, wrong button. So phase 1, So this is basically it. So we have a consultant on board through our as needed, Soma Bajra, with Proteus Consultant. She's helping us set up the RFP for the program. So she's not doing the asset management plan, but she's an asset management expert. She works with EWA. She works with City of San Diego on their asset management plan. She's worked with City of Carlsbad. She actually spent 4 years in Australia, and that's the birthplace of asset management. Setting up asset management, for building 2 separate large regional wastewater treatment plants.
She's
And-
kind of played the role that Kevin Ross plays
Yes.
on the solar side, kind
Oh,
of
okay.
advocate, looking out for our interests.
Yep. So she's right now basically, and I won't go through each item, but she's basically reviewing our systems, setting up where's our baseline, where's our starting point. She's helping us set up an RFP to get an asset management consultant to actually do the program. We want to make sure that we put a good scope out because we feel that we've done certain things right within our different things like our CMMS and our finance and our capital stuff. And she's saying, do we have all the information necessary for a consultant to go out? Because the last thing I want to do is go out for a consultant, they make an assumption, they put a scope together, we get into it, they go, ooh, nah, that doesn't meet our assumptions, we need a big change, it's going to take an extra year. So we're trying to figure that out now ahead of time, and so we scope it correctly. Their task B is basically working with that consultant, working with staff, and figuring out how to, because at the end of the day, at the end of that 3 to 5 years, when the consultant has built the program and we have basically the processes in place, somebody's got to run it. Because the consultant's not there to run it, to do the evaluations. There's consultants that are working on stuff, but at the end of the day, somebody's got to run it for the district to assimilate it, to get the information, process the information, and then go out with the decisions based on what the program says.
Question.
Yes.
So this consultant is in addition to the asset manager that we have in the budget.
Right.
Yes. So, but at the end, the consultant work's really a 3 to 5 year effort, and after that, the need for the consultant on the asset management side is minimal to none.
Mm-hmm.
Condition assessment is really contractor work, and that's ongoing. But so as you're getting the information gets plugged into your program that the consultant set up. It spits out results, and those results need to be analyzed, and then of course assigned. So you could envision a world where Jason will get projects for next fiscal year based on priority. Hey, these pipes look like they need replacement based on what we found out, or operations will get hey, within the next 6 months these look imminent breaks. You need to go out there and do spot repairs on them. That'd be ideal. Whether we get how long it takes to get there, I don't know.
So that's where I think we're going to hear some rub.
Sure.
Because that's what I'm sure some of us, I thought that's what the manager was going to do, was do this assessments.
Supervisor,
Well, whatever we got.
asset management supervisor.
Yeah, whatever his job title
Yeah.
was. He was going to gather this information. He was going to
He's going to be in charge of everybody to do it. Yes.
Well, he's in charge, but we've got a consultant who's supplying them the information, if I understand correctly.
No. The consultant's setting up the program. This consultant's setting up the asset management program, and then they're gone.
Right.
And then from there, he's the one that's getting the information. He's the one disseminating the information. So we're on the same page.
The information that's coming in though, it's coming in from our field staff,
Right.
from breaks that they're taking, or it's coming in from our CMMS person who's entering the data. So different staff groups are putting
It's
that
coming in
data
from finance.
Right.
into the
Yeah.
program.
That's coming into the supervisor.
Yes. And then he's outputting the priority of what needs to be done.
And the consultant is supplying information to.
No. Consultant's setting up the ability for him to get that information.
Kind of building the system.
Building
Yeah.
the system.
Yeah.
Consultant's building the system, and then
And they just give us the
the
keys.
new position is the one that's utilizing the system.
And it's good to have that new person involved right from the
So,
start. with the
exactly, we need them
And
there.
that's
day one.
why it's budgeted this fiscal, or the proposed budget is for this fiscal year, because the last thing we want to do is build the system and then have somebody come in and say, ooh, if I was part of this process, I would have done all this different, let's change it.
And over this 3 to 4 years with a consultant, what's that going to cost?
Well, Soma's contract's $40-something thousand, to set up the RFP. When we get to the RFP, it's going to be over the $50,000 mark, probably in the several hundreds of thousands. I've gotten quotes as high as $500,000. So, but that has to come to the board.
Yeah.
So, and when we talk about in finance committee, the finance committee was supportive of the consultant work. Wasn't sure of how the staff would do it. I think there was a vision that they had that the consultant just could do it every
Yeah,
year.
why can't we just consult the whole thing out on a permanent basis?
Yeah. So, but that would be several $100,000 a year for a consultant to do it.
Yeah.
So,
Okay.
And,
so
we know, and, excuse me, James, in early years, the asset management supervisor will be working with the consultant to develop, but they'll also be overseeing things like condition assessment, although condition assessment isn't the only thing, that's something that they will be doing early on
yeah.
in conjunction with working with the consultant.
Yeah.
They'll be busy.
Yeah, they'll be doing condition assessment. They'll be doing cathodic protection because we don't have a cathodic protection program. So starting at the picking up the cathodic protection program. They'll be doing rehabilitation jobs, and so basically asset rehabilitation, and then working with the consultant to build the program. So.
So, you've been talking mainly about horizontal assets, in other words, buried pipelines.
Yeah.
You're gonna include all assets?
It's all assets, yeah, vertical.
Like buildings, pump stations,
Yep.
everything.
Yeah, so our vertical asset
Tanks.
hierarchy is already well established within our computer maintenance and management system, and our horizontal assets are not. So there's more building to do with the horizontal assets, and while our vertical assets are fairly developed. So, but we're going to be doing both.
Yeah, so when we talk about running those pumps to failure, that information.
Yep. We're
would be very helpful.
Tank coatings. those
tank
kind of
coatings.
things.
Yep. Tank coatings are coming up. So.
We'll talk about them today.
We'll talk about tank coatings today, and we'll Jason has a great picture of what happens when you don't coat a tank in time.
Yep. You
So-
don't refurbish it.
It's like asphalt pavement management.
Yep.
It's
Yeah.
the same thing as tank coatings.
Yep.
If you don't do something to it, then you lose the whole thing.
Yep,
There's a knee in the curve and it just drops
and,
off.
and it's going to equate to
So,
something.
pavement's another one that's good for asset management.
I mean, that's a
Everything has a life
not
cycle.
not to jump the gun too much, but the tank cone's a perfect example. We waited too long between periods, and now we've lost steel, and now it's a fairly significant change order coming back. It's gonna probably come back to the board, I'm guessing.
I think we'll stay under the 10%, but just barely.
Yeah, okay. But it's still a pretty big change
it's
order
a
for us.
big
So
chunk.
you got rafters that you gotta replace.
It basically just
We're
moves.
hoping we just plate them, and but there's maybe one or two to be replaced.
Yeah. But based on the pictures, the paint's there, so it looked perfect.
So you poke
It didn't
it.
look like this.
Yeah.
So capital assets, what do we own? Where are the risks? When do we need to reinvest? How much would it cost? And how do you do it? You replace it. Do you rehab it? And of course, maintenance, work orders, locations, parts, maintenance costs. All those things are taken into consideration. Sometimes we maintain things that we should replace. It's costing more to maintain it. So where's that decision? How much money are we wasting doing that? We don't really know. I think we do a good job today, but we also have 30 to 40% of our workforce retiring within the next 3 to 5 years. So we're going to lose a lot of that knowledge. So the idea is to capture a lot of that knowledge into a process and program before they're gone. Because the next group coming up may have that knowledge, may not. I don't want to take that risk.
Mm-hmm.
So high risk assets, you got to prioritize it, replacement and rehab. You got to monitor performance conditions. You might have to condition assess it more often. Preventive maintenance, obviously. Redundancy, backup. Make those decisions. Do we need backup for everything? I don't know. If our policies say we should for our water systems, but maybe we don't on certain things.
Well,
So
I think you do a criticality
Yep.
assessment
Right.
to figure out where you have like a single point of failure.
Exactly. So, and then the cost estimates approach. Is there a short-term solution? Do we do that right now? Long-term solution. Where do we invest the money? So, phase 2, I'm gonna kind of just go over this quickly, but it'll be done after phase 1, and it's starting to utilize all that data. So, for years and years and years, operations has been doing their computer maintenance and management system, and we've been collecting data on an asset, whether it's a pump or air conditioning unit, or a tank, or a piece of pipe. Anything that's been done to that has been done through a work order process, and we have data collected on it. What do we use it for right now?
Yeah.
Nothing. Okay? The reason is we've pushed off asset management since 2012. It's been we don't have time to do it. It's been the easy one to push off during the post-recession. And so we're collecting all this data for a reason. Are we collecting the right data? I don't know. I think we are. It was set up initially. That's what our consultants are going to help us figure out. Do we need to collect different data to get the information out of it? Maintain cost budgeting planning, so forecasting tool. That's what I was talking about. As we have a replacement schedule, what's the proper reserve amounts that we need to? How much money are we looking at? And from there, we can make decisions on scaling back or accelerating. And standard procedures. Do we have everything in place? Where does the process go? When something happens that's non-emergency, what decisions do we make before we just start spending money on it? And then, of course, customer service with our financial systems. We got to look at how we run the system, our connection with the customer service system, the financial system, planning, asset management. So these are just a couple figures. You're looking at an asset cycle. You plan, you budget for it, you design, you construct it, you operate, maintain it, then you rehab, renew, or you replace or you retire it. It's pretty simple. It just goes round and round. If it's a pipe or a pump, this is a great example for like a pump. This is what you do with the pump. Rehab it, oh, time to replace it. So if you look at a typical asset, you have, it's new, right, and then it starts degrading. And then initially you don't have to do much. Then here's the rehab, and here's the replace window. Once you get here, it's pretty darn expensive. So what basically we're doing is making informed decisions based on data that we're collecting to reinvest and extend asset life. Reinvest, extend asset life. It doesn't mean that pieces don't need to be replaced. It doesn't mean that money's not going to be spent, but you're spending less money and you're extending life. Every time you could extend life, if something's supposed to last 50 years and you get another 25 years out of it, that's great. It's like holding onto a car, right? If you hold onto the car, the longer you hold onto the car, and this is what Jason does, and Rob does, because they're smarter engineers than I am, and even though there's maybe more maintenance costs, it usually works out for better. At some point, though, that's kidding. At some point, it doesn't become worth it. The maintenance costs, the liability, the risk outweigh the fact that you can save some money.
Well, I'm embarrassed because I've got a pickup truck in a parking lot with 360,000 miles.
You should not be embarrassed. You should be proud of yourself.
Engineer strong.
So go
Not
back,
caving into those commercials.
James, go back one.
Sure.
So one of the criticisms, James shows this infusion of cash during the rehab time frame to get it back up to like a new condition.
Mm-hmm.
Some people may say you had a lot of life left. You could have run it all the way down to the bottom. So that's the thing that we need to make sure that we're making those informed decisions and we can defend the decision why we invested a little bit of money so we didn't have to spend a lot of money.
Yeah. And that's actually very true. And I think the next slide kind of shows it. So there's certain things that have very little consequence of failure that it makes sense to run to failure.
Yep.
Okay. But right now, from a culture of our and it's a good culture that we have here, is we don't want anything to fail. So we're going to spend and invest money to fix it. That's just a culture operational. Don't let anything break. Have a replacement part. It's a good thing. It's not a bad thing. This is to make that educated decision based on data of, hey, it's okay if we don't spend the man hours on this piece of equipment here because we have an automatic backup. It's not critical. But of course, when we have critical things like, and the critical is not just the typical, it breaks, it does a lot of damage. It could be environmental factors, it could be economic impacts. We have a lot of customers out of service, societal, bad PR. I mean, there's a court of public opinion that plays into this too. If we take out a home, that's not good, even if the home is going to be cheaper to replace than the pipe. So, so those things take into account. So it's not pure dollars and cents.
Yeah, I use this for like valve replacement,
Yep.
a valve exercising program, because if you let that go, and you defer it, then your shutdowns go from
Way bigger.
20 homes to 200
Yeah.
homes
Yeah.
to 2,000.
And that happened to us over at Rock Springs when we were doing work. A valve didn't hold, and all of a sudden we had to shut down the fire surface of school, so we had to cancel and wait for spring break to do it, right?
Mm-hmm.
So it then impacted the job.
So I use this justification to hire more people to do more valve exercises.
Take a note on that.
Yeah, I got
So, and then probability of failure. That's the other thing. How vulnerable is it? Basically, what's the probability of failure? New, low probability. Older, higher probability. Bad soils, bad condition, history, all those things take into
Yep.
effect. And then, condition asset related decay curve. This is just the same curve. You can see kind of like new, and as it decays, the probability increases of failure. So current efforts, what are we doing now? This is in this budget for board consideration. We are looking at a pipeline condition assessment of steel transmission mains. We talked about it a little bit, and I have a slide, so I won't spend a lot of time on that because the next slide kind of shows what we're doing. And then we also have a ductile iron main. Now we have 200 and something miles of ductile iron in the district. It's a lot. So that ductile iron program is probably going to be an ongoing program, while the steel program is limited.
You say there's 200 miles?
Of ductal iron, there's like 538 miles
That
of
sounds
water
about
lines,
right.
but most of it's AC. I think the ductile iron's in the 200s.
Oh, I didn't realize it was that much.
Yeah, so
You're ductile heavy.
yes, we're ductile heavy. So we're looking at trying to figure out how much where this program, and we have VNA on board on this already, is to look at where do we go first, and how many miles or how many linear feet of pipe can we afford to do? What makes sense to get the areas? Will we do every single ductile iron pipe in the district? Probably not. We're going to go after areas that are more likely to fail. Higher pressures, a lot of times maybe built during the boom where those people are building faster. We're looking at all those factors. Soil conditions. Jason just developed with Lee and working with operations. So Jason, our inspection supervisor in operations, together developed a log, basically a checkbox of every break, so to capture information to put into our system for asset management. So we're going to have soil tests done. We're going to have basically certain information put in, so we're capturing consistent information at every break to get more data. Now these things will be fruitful, but it will be down the road when we start actually collecting this data before we can actually do any analysis. But if we don't start,
Yeah, right.
yeah.
Yeah, it doesn't help us now, but in
Yeah.
5 years, it could be valuable.
So here it is. So here's the Trace Amigos pipeline. I kind of alluded to this at the board meeting last night. So show up. There we go. So really quick. Whoops. It doesn't work. I'll get to that, Jason, right there.
Yeah, just
There
double
we go.
click it.
Maybe.
You gonna replace that
It's,
speaker?
Where'd it go?
It's
right
up
there.
above, you gotta
Okay.
click it.
Okay. So here's a ductile iron. Here's a steel line that connects our north area, almost up to Gopher Canyon, basically, to our terminal storage here.
From the hand, it helps me a little bit too.
Okay. To our big Twin Oaks tanks. There's a pump station here. Basically, it's the only connection to our really big storage. There's storage up here, and we do have an aqueduct connection up here. But if that's severed, this area only gets water from this 12-inch line. We've had several breaks in this line over the years, and the line's pretty old. This area we know is really bad pipe. It's pipe that we inherited from a farmer. It's actually tar wrapped steel. And it's so thin that a welding rod just burns through it. So we're going to replace that, no matter what. But the rest of this pipe, we don't know. It's CMLNC, it's steel pipe, and we don't know if it's worth replacing. If we replace it, it's like a $9-10 million job.
How old is it?
I'm going to get to that.
1964 to
So-
19, some earlier stuff, 1958. That's
So,
the stuff we inherited.
yeah. Okay, so
Probably
basically,
at the end of its useful life.
yeah. And I think I erased that figure on accident. So 1958 to
You
1964.
made it really, really small.
Oh, there it is. I did. Whoops.
As you can clearly see.
Yeah, so now you can see the whole thing. Just kidding. And basically, we track the breaks, and we're looking at focus areas. And so, really quick, the way we look at it is this: is we have 3 phases of replacement. Here's all the lineal feet of cost, and if you look right here, Here's your replacement costs, $9.1 million. That's part of those future projects. Remember, what are those future projects? I said there's a big pipeline of future project that replacement costs. Now, if we do a condition assessment, our consultant told us, well, we're going to replace this section anyway, so don't worry about condition assessment there. But here's $180,000 for this section, $200,000, $380,000 in condition assessment. From there, we're looking at kind of the asset management standards, especially steel pipe, that says up to 80% of the steel pipe is in good condition when it's replaced.
Even when it's that age.
Even when it's that age, yes. Now, it doesn't mean we're going to be that lucky. This is kind of a nationwide industry standard. Now, well, I take that back. It's a west of the Rockies standard, because they said when you get east of the Rockies into older systems, and they're not seeing results as good. So we made an estimate. Now, the cost of spot repair and spot replacements is more expensive than a big linear job because you don't get the economy of scale. But you're looking at costs of basically assessment and repairs at $2.4 million. You can see somewhere around $6.5 million savings right there, with assurance that the pipeline is in good condition when you leave that. So now you could. This is a big project. We don't have big projects this big all over the place. We do have a few others. We have basically 3 large steel lines that we're looking at doing. This one, the one that goes underneath those houses that go out to Escondido that we talked about, and there's one other ones that kind of go, the one that broke basically, that go around Twin Oaks. So those are the lines we're going. So the steel assessment program will end. There might be recommendations to reassess it every now and then, but it's not a continuing, ongoing. While ductile iron, with 200 miles of pipe, will probably never end within my lifetime, at least. Because if you're only doing a mile or 2 miles a year, it's going to take 100 years if you do 2 miles to do it, and we can maybe only afford to do 2 miles a year. And now, granted, we probably won't do the full 200, but there's a good chance we're going to do 100 of it. So then it's a 50-year program. So it's a long-term program. So I want to give a definitely a flavor that this is not a done in 3 years and we don't have to do anything else. So, but if you look at the savings,
even in James' analysis, that 70% that is deemed to be good right now, that isn't going to be repaired, sooner or later, it's going to have to be done. It doesn't last forever.
Yeah.
Well, it's a 60-year-old pipeline.
Right.
Yeah.
But some of it may last 100 years.
Yeah, but it's all about, like, extending the life. If we can get
Yeah.
another 20 years,
But
another 30, whatever.
We've had breaks on that pipe, and the reason why we use this as a good example, we've had breaks on that pipe, and it's been a spot repair, and the pipe looked beautiful. We cut that pipe out, and it looks beautiful except for that spot repair.
Is it adequately sized otherwise? Is there
Overall, we have some developments going through it, and with the new fire flow requirements, so some of the developments will replace sections. So one of the things we're going to do is, well, we don't know if the developments will move forward because they've been on the books since the 90s. But if they do move forward, we're not going to assess those sections. So we'll probably wait and push off assessment of their sections last as a decision-making process. But they're going to upsize the 16 for new fire flow requirements. So with that, current efforts, is we kind of put this in slide in twice. So. Notice it. No,
Yeah, there's other stuff we're doing.
Other stuff we're doing. So we're also on the sewer side. We've never assessed our land outfall gravity sewer. It's ductile iron gravity sewer, and if you guys know anything about ductile iron and gravity sewers, the gases form at the top and eat the roof. If it's submerged and all the way, we're pretty confident that the ductile iron sewers are good. But when it's not submerged, that's where we've seen breaks. So we have a lot of ductile iron gravity sewer in the outfall that was put in the 80s. That it's never been assessed.
Okay, but leave it alone.
What's the line? Is the line epoxy?
No.
It's cement?
Yeah.
No, it's
Yeah, that's
not good.
that's what I mean.
And it's thin,
It's thin.
very thin.
Yeah, they just put in basically water pipe.
Yeah.
So we are also in the budget is cammering that, and that's a large effort. It's a large pipe. It's going to be hard to get in there because you can't shut down the flow. So we're talking about 2 a.m. inspections. So and of course cleaning and then getting a recommendation for rehab repair. And then what I kind of jumped the gun on the other one, the tracking the leaks, the mapping, the soil samplings. We have GIS layers now of break data, and then we're gonna basically attach this information into our computer maintenance and management system that Jason, our inspector, supervisor, and operations kind of came up with, and start collecting this data. So we have a lot of balls in the air, and they're all moving forward slowly. And what we're hoping is, obviously, with the new position, that they would take these balls and move them together uniformly and at a faster pace.
James, so you mentioned that the condition assessment is in the budget, the asset management supervisor is in the budget. What about the consultant? Not the SOMA, but the...
No, it's that portion. Yes, we have an overall budget for it. So yes, it's in the CIP. That's in the CIP budget. Yes, the consultants in the CIP. We have a guesstimate of what that would cost. We'd actually have to go to the board and make adjustments if it comes in higher than the.
Right, but assuming our estimates were good,
Yeah,
the budget that we're going to be asking the board to approve would allow us to move
Yes.
forward with everything that we're talking about.
Yeah, the only thing. So if there's emergency repairs that come out of some of these assessments, that's not in the budget.
Right.
That's about it.
I've got a question on the land outfall,
Yes.
gravity sewer. Now, the CIP, there's a huge project to parallel that, right?
The gravity sewers are replacement. There's no corridor for parallel.
Okay,
Yeah, the siphon is a parallel.
okay.
So
I thought we had a parallel line.
siphon, only the siphon.
Only
Siphon
the
A,
siphon
siphon, which is
section.
it's 11,900 foot siphon.
It's only a portion that currently exists. That's a parallel.
Yeah, so we're looking at paralleling about a mile of it,
Yeah.
basically from the Laurels community, where the siphon starts, to Melrose. We know we have a corridor, and from there we have to study whether it makes sense to replace or parallel. I'm leaning towards paralleling the whole siphon, but the top section is the most important because that one is fully submerged to unsubmerged every day. It's air, sewer, air, sewer. The next section, because it's lower, is fully submerged all the time, so we have a better feel that that's in good condition.
Didn't we just recently have a spill?
Yep, right, the Laurels.
Alleged spill.
Alleged
Sorry.
spill,
So that's pretty much it. I don't know if the committee has any other questions, but basically there's a lot more slides that as part of this effort, and our consultant Soma put together the base, and she kind of threw the whole kitchen sink at it. So we kind of gave you an abbreviated version of kind of what we're looking at doing. Hopefully you get kind of the idea that it's much more than just condition assessment.
Have you guys taken the EPA asset management training?
I have.
Yeah.
Yeah.
That was kind of the first or the original.
Yeah,
In the
for the
States.
states, yes.
Yeah.
So the IAM group is actually a British group of their standards, and the EPA adopted their standards, and the British group adopted the Australian standards. So so if you go back, it all goes back to Australia in reality. So
And
and
that's been like 15, 20 years ago.
yeah. So and of course it's evolved with technology. So I mean, Water Authority has virtual reality VR mask that you can put on, and it shows they have this machine that has like 16 cameras on it that goes down the pipe,
That's why our water's so expensive.
and then you could put on the
pretty cool.
VR and go like this and look at the side of the pipe, look at this side of the pipe. You can look at so if you want to see something, it's pretty cool. I'm not suggesting you do that.
Not yet.
Not yet. That's gonna be. I'll budget for it. I'll make sure you know
Right
that.
after we get that drone, then we're gonna get that.
Yeah.
Yeah. Well, not drones from China though, because they're spying
Oh
on
yeah,
us,
yeah,
so.
yeah.
All right, from a time check perspective, it's 4:30, so we're ready to move on to the...
I'm good.
Okay, so I'm gonna
Good to
hand
go?
this one. Yeah, I'm gonna go. I'm gonna hand this one over to Jason
Okay.
to take over. And
We'll make it quick.
thank you guys.
Thanks, Gene.
Thanks, Jim.
Thanks, James.
We want to save all those changes he did. Okay, so we're gonna do real quick, just a quick update on the CIP projects, and that's for our third quarter from January to March. And actually, I'm gonna let Lito drive. Lito Santos is our capital facilities engineer. He's working on a lot of the projects in construction. I kind of set it up, handed it to him, and he runs with it. So I'm gonna let him carry the ball here, and we're gonna make it quick.
Okay.
Hint, hint, hint.
Thank you. Jason. All right, directors. So I'll be going through the CIP improvement projects that we are managing from January through March, and we just updated the BWD site, and we try to update this quarterly. We lag about a month tops, so we just updated it back in April. On the website, you can pull up the page over here, but I'll do a quick demonstration on how you could get it going. So if you go on vwd.org, which is open to directors, customers, anybody that's general public, you go to the engineering link over here, drop over to capital facilities, and there's the active improvement projects that we have.
Buffering.
Little bit more
lag.
lag.
Gotta update that server there.
Yeah.
Uh-oh.
Slow.
Apologize for
going
the
on?
lag over here. So if you blow up the map over here, there is the 10 active capital improvement projects that we are currently managing from planning through construction. And since we're speeding it up here, rather than going through these 10 projects, I'm just going to highlight the 3 that were in construction right now. So if you click over here, you have the brief description of the project, and then if you click on the bottom link, it's the actual third quarter page. You have title, description, quarterly update, any change orders that we are negotiating, outstanding issues, and then we have a map. And then on the right, we have the financial breakdown. Starting with Paulus Vista Pump Station, that's in construction. It's an electric generator that is over at our Richland tanks. And the purpose of this is to install an electric generator in case power is ever cut off. We could supply water to the Emerald Heights community up there off El Norte. So far, we've this quarter or last quarter, we conducted a pre-construction meeting and issued a notice to proceed for the contractor to get going. The next project we have in construction is Rock Springs Sewer Project. It is a 3,000 linear foot replacement project. We're replacing 8-inch VCP and upsizing it to 8 and 12-inch PVC pipe. In the third quarter, we just completed about halfway through the project with the pipeline, installed 10 manholes, negotiated 7 change orders, and we're due a credit of $102,000 at the end of that quarter. It's a $2.1 million project for the contractor, 3.1 for the district.
Don't get too excited, Jim. That was last quarter.
Yeah.
It's slowly getting eaten away.
So,
What's the total length again?
it's about 3,000 linear feet.
3,000, and it's 2.1 million.
Mm-hmm.
That's a construction cost from
Yeah.
from the contractor.
Next project is over in San Alejo. It's a schoolhouse tank. We spoke briefly about it. It's a 2.4 million gallon tank. We completed the plans, advertised the project, received bids, legal reviewed it. We did background check. We did 20% of the design is now completed, or 20% of the consultants' fees are up. They're also doing our construction phase services, and that's why the percentage is so low. So back to the slideshow here. I'll go ahead and share some of the photos that we have.
Everybody loves photos.
So this is Paul's Vista tank, and this is where the electric generator will be sitting. It's an equipment pad. There's the double mat foundation, some of the conduit that's been laid and along the trench, and the contractor is pouring the foundation. This is a pretty substantial generator. It's I think it's about 300 kilowatts. So,
Yeah, 350 kW, I think.
yeah, and it's to power, I think.
And it took a while to get this generator because of the APCD rules with air quality and stuff. So this has been we've been waiting to get this, and I think it's due in July now.
Yeah,
to be delivered?
we should be wrapping it up hopefully by July. So
This
and
is diesel powered.
yes,
What
yes.
kind of housing will be placed around the generator?
It's self-enclosed. It's metal.
Okay, it's
Yeah.
one of those. Okay.
Yeah.
Yep.
We'll bolt it down to a substantial equipment pad. So it
Looks
was
like a pretty
typical.
hefty pad there,
Yeah. Yeah.
about a foot thick.
3 foot foundation.
Yeah, you gotta see the foundation all around the perimeter
Yeah.
of it. Yeah.
Wedge anchor bolts, so it doesn't turn over or anything. So it's pretty solid. Next picture, we have a Rock Springs sewer replacement. Like I said, it's a 3,000 linear foot project, and we just we're up to Rock Springs right now in Matthews. If you guys are familiar with the area,
Yeah.
that's Woodland Park Middle School.
Yeah, this has
And-
all been completed up to here, and it was just this last piece that we're working on now.
Yeah, and on the bottom right, we got waters of the U.S. we had to protect, and we ran into some rock. And this is just an example of what we do to rock. We just bust right through it. Have a big
So
old
we talk about
330.
that CEQA process. We had to cross the waters of the U.S. 5 times for the
Yeah.
project.
A concrete line ditch is a
Yep,
waters
yep.
of the
It's
US.
just, it's just a concrete ditch.
Yes, but we got right under there with that nice breaker and was able to punch that hole and get the
What's
casing
the
through.
source of the water? Is it just irrigation runoff, or
It's
is it actually
Stormwater.
a creek?
well, the groundwater here is very high.
That's the Rock Springs.
Yeah, it's Rock Springs, and in fact, that little
That's the
brow
same
ditch
portion.
during this winter,
Just comes out of the
it
ground.
up tops and it fills the whole corridor of this green space, kind of a linear park strip area that this is all in.
Some challenges on the project.
And just because it's kind of curious, you talk about the groundwater. So these are our manholes. We're actually this has actually got an exterior waterproofing coating from the manufacturer,
Ceiling.
and then we're sealing those joints. So not only has it got that mastic, but then we're doing an exterior seal to and this is because we want to control I&I, right? So that's less
Mm-hmm.
infiltration getting down to the treatment plant that we're paying to treat. So it serves a lot of purposes.
Yeah, I was the construction administrator for the school district when they built Woodland School.
Okay.
With and we had the
Ground-
change orders that came with Rock Springs.
Yeah.
That thing was just water shooting all over the damn place.
Yeah, that's the reason why they call it Rock Springs.
Yeah, that's
we got,
right.
We got rock. We're breaking rock, and they're pumping out groundwater
Yeah.
at the same time.
So change order wise, we're doing pretty well.
Good.
We're hoping with the last 300 feet we finished strong.
Yeah, good.
Last we have the schoolhouse tank up in San Elijo that we're refurbishing. Contractor set up the scaffolding, started sandblasting, and we found some corrosion in the rafters. So we'll need to repair that prior to recoating it. So.
Yeah. So right now we're looking at probably $18,000 in extra sandblasting inspection, and then after that, then we'll determine how much structural rehab, rafter replacement we'll have to do, and I'm guessing it's going to be around 20,000. Still be under our threshold, so we'll still be good, but it's not ideal. But this is a project that got we deferred this project several times over the budget years because we were trying to save money, and the inspection that we had, it looked good, but you can't see what's going on underneath, and
Yeah.
it turns out that this one caught us off guard. So.
Any questions?
And these are just 3 projects. The map shows about 10. We're
Yep.
actually working on many more than that, but those are just 10 that we can really give you some good information that we want to share with the public. But there's a lot
Good.
more other things we're doing.
It's a
So,
nice little website. If you guys haven't played with it, you should get on there and click on
Yeah,
these
click
projects.
around.
Yeah, and if you have any questions, we can expand on some stuff or give you some
No,
information.
that was very informative.
That 3,000 foot sewer project,
Mhm.
that's a pretty high unit
Yeah,
cost.
$700 a
Yeah.
linear foot.
Well, there's
Is it deep or is there special?
the groundwater is high, so there's a lot of bypassing, sewer bypassing. There's
Okay.
a little section that they actually have to line about 300 feet, so that's in there. There's a lot of traffic control once you get up into Rock Springs, and all the work in Rock Springs is restricted hours, so it's 9 to 2 because of the school. So that means your production goes way down. We've got a number of high 6-inch gas mains that we have to cross, so there's a lot of utilities that we have to deal with, and there's a lot of restoration. So all that park space that we're going through has to be restored. There's new access roads being put in, all the pedestrian sidewalks, the undulating
Mhm,
sidewalk has
yep.
to get replaced, some light poles, benches. So there's a lot of restoration costs as well.
What was the bid climate like? Did we get a lot of bids on that project?
We did, yeah. It was, in fact,
At least
the
eight
second bidder
companies.
was only maybe 14,000 or
Yeah,
something.
really
25,000,
tight.
yeah.
Yeah,
there
it
was
was pretty good,
contentious.
Yeah.
and there was
It was
a
challenging.
good.
High
What was-
confidence level that
What was the
that's,
engineer's estimate?
I want to say it was 2.4.
No, it was
Or
way
2.3?
lower. It was within 3%, 2%. It was a very
See what was
small
lower than the bid.
portion.
It was higher than the low bid. And there's also, like I said, that waters of the U.S. It's trenchless tunneling and has to be done we cross it back and forth like 5 times, and that's a substantial cost.
This is a dig and replace.
I wish it was
project.
just a simple,
Yeah,
you
dig
know,
and
3,000
replace.
feet in the street. No,
Yeah.
you know what I mean. But
Yeah.
this one's very complicated, and there's a lot of environmental restrictions that we have. We have monitoring going on. There's bird nests surveys that we had to do back in January.
Oh,
so
and
we're
there's-
not gonna use this experience to project future costs of
No.
dissimilar projects.
No, we kind of look at it and we try to compare, you know, apples to
Like
apples as
projects,
best
yeah.
as we can. Yeah.
There's also a 16-inch high-pressure gas line along the Roxbury
Of course.
portion.
Yeah.
Yeah,
And they roped certain sections.
Yeah, and
so
actually
that's
just last week, Leo and I kind of negotiated with the contractor that changed because the pothole data that we had didn't accurately show where it was. The contractor went out and did some more potholing, found it was closer. We had to get with SDG&E, do some coordinating with them, and we ended up removing our pipe a little bit, and it's going to cost. The initial change order from the contractor, you love this, was $1 million. We said, well, we're done.
Yeah, let's
So-
refigure this.
So we refigured it, and we're at about we went with 20,000.
Oh, there you go.
That's better. Yeah.
There's some additional items, bid items up and down, and all said and done, it's probably going to end up around $100,000. But because there's some T and effort in there and stuff like that, we can't quite know. It's much lower than $1 million.
Yeah.
So
Well, good.
it's
All right.
Yeah, thank you.
Yeah, perfect.
Very informative.
All right. Any other business? I have one,
Us.
just the septic study.
Okay.
I had mentioned it to Scott just at our EWA meeting, said that you guys were gonna get with him.
Yep.
Good.
Yeah, I've already mentioned it to him. I want to chat with him about that.
Okay.
He's a likely suspect.
Yeah.
To help us with Betty.
Yeah, picking up most of the Encina
Yep.
information.
We're gonna kind of back it out, and we're gonna say, how much can you give us for $30,000?
I said less.
Okay.
Yeah,
Yeah.
we wanted to be under 30. Oh, good.
So for future meetings, I find the development updates.
That's
are
gonna be at
really-
our next one.
They're really
Yeah.
interesting.
Yep,
so
yeah,
they're
we'll get
really useful.
development services. There wasn't a whole lot that was going
Yeah.
on, but,
Okay,
so we're probably gonna do that one, I think, twice a year, that
Yeah.
we decided on, as
Good.
opposed to 4 times a year.
perfect.
yeah, I think our plan for CIP is we typically do an end of year report, and that's usually in August. So if that's the appropriate time to actually bring the development stuff into,
Yeah.
that would be.
Yeah.
Good.
Good, all right.
Okay, great, thank you all.
Thank you, Ann.